Hello and welcome back to stage one. I hope you had fun with Alan if you were here already earlier. And we are continuing in the kind of more technical topics during this afternoon. Have your coffee ready so that you don't sleep after lunch, and be ready for Kim Clark from IBM. And Kim has recently given up coffee, I hear, and you're still looking so sharp and awake. That's amazing. So I'm really glad that you're here with us, and I'm waiting to hear about everything is an API, but then you have some like diversity thing going on here with APIs. Equality. Okay. So take it away, Kim, and go ahead.
Sure. Thank you. If you could let me know if the slides are on the screen, and I will get rolling.
They are fine. We are ready
Very
to go.
good. Great. So yes, so Kim Clark, I'm from the Hersley Labs in the UK for IBM, where we make a lot of the integration portfolio. And I spend most of my time working with customers who are modernizing integration landscapes. We talk about that under the banner of a phrase, agile integration, which covers many different topics, many different aspects of how to modernize an integration landscape. But as it's unsurprising to this audience, I'm sure, that moving towards an API-led approach is a really fundamental part of that. A heavily summarized diagram of agile integration looks something like this. There's much more rich and complex ones that we have, but you can see, most customers are moving from a very layered architecture with technology silos, perhaps whole integration teams and maybe API management teams and things, as well as sitting alongside their application teams. And generally where they're trying to move to is more autonomous groups or more autonomous teams that are able to perform their own integration and expose their own APIs. And so really a fundamental topic in integration becomes, how do you expose those APIs? What do they look like, and where are they coming from? But there's been some really interesting changes as we've moved from this sort of layered-based architecture to a more application-centric architecture. And one of those is around how do we group and recognize the different types of APIs that we have. If we go back to the layered architecture, we had a fairly sort of rudimentary way initially of separating different types of APIs, because we could talk about things that were APIs exposed within the organization, within the enterprise, and things that were public facing. Or to put that another way, things that, from a network point of view, had east-west traffic that moved within perhaps the data center or the LAN, and things that were coming through the front door and through the demilitarized zone and so on. And that type of definition of APIs was kind of a false definition in a way, because it doesn't really talk to anything more than what's happening at the network level. And of course, when you move across to the right into the more cloud-based way of deploying things, potentially using multiple different clouds and an on-premise data center, potentially everything becomes a north-south type of traffic. We don't have this definition between, some types of traffic that's within the enterprise and other types that are not. Even in the same cloud provider, we might find that our routes go through a public network on the way between one application and another. So that sort of definition of how our API is different no longer really works once we move into the cloud. Another way that we used to categorize APIs was by the type of protocol that was used. And of course, the phrase API goes back a long way before the REST APIs and web services APIs that we've been talking about in recent decades. It goes back to things like, the API between two pieces of Java in the same application. They'd be communicating in memory. The way that two different applications in the same cluster might talk to each other, perhaps over a Corba network or something like that. And then only then would you get to a point of saying, well, some of those functions I'm going to expose outside of an application and make them available more generally over the things that we nowadays talk of as APIs, so REST and SOAP and so on. So in the past, we used to be able to sort of say, well, if it's internal, then it'll be an IPC communication. If it's across the cluster, it'll be Corba and so on. Again, that doesn't work in a microservice application. In a microservice application, a modern, more decentralized application, we've started to break up the pieces into each having their own individual container that's sitting on the network. They've got their own application server, their own container, and so on. So pretty much everything is a network API call. They might all be REST API calls. So how can we differentiate now between something that was a call between two parts of an application, a call across applications, or a call that's exposed beyond the enterprise boundary, when they're all essentially the same protocol? We could start to think about, well, do we want to bring those boundaries back? And we'll talk a bit more about that in a moment. Maybe those boundaries are useful, but the boundaries aren't held by the same things they used to be. So, in a container environment, we're no longer dealing with a one-to-one relationship between where an application sits and the operating system or the infrastructure that it sits on top of. The container environment, container platform, is going to be redistributing things. It's quite happy, Kubernetes is quite happy to kill one of your containers in a pod and move it to another operating system location at will, because it thinks that that's a better use of the resources that it has. It's allowed to do that. That's part of the benefit of being there. Indeed, we're not able to say exactly which infrastructure we want things to sit on, or at least we shouldn't. We're allowed to specify certain affinities. I'd like these two containers to be together on a node if possible. I'd like these two to be separated, perhaps, because I want them to provide high availability. So I'd like them to live in different regions and things. But we can't hardwire them to a specific operating system. And so there is no real relationship anymore between the application boundary and the physical boundaries, or indeed the network boundaries that sit underneath. So then we come to an interesting question. So, okay, so maybe we decided to reintroduce these application boundaries to help us to decide what APIs are doing what jobs, and, whether they're inside an application or across applications or so on. But how do we actually enforce that? And that's quite a challenging question, actually, in Kubernetes terms, because there are a lot of different options. And customers I speak to have used all sorts of different techniques. So you could group an application together by saying it's in a specific Kubernetes namespace. Now, that doesn't actually necessarily network isolate it. It might do if it's the equivalent of a namespace in OpenShift, for example, as a project, and projects can have network isolation. But that's one way that you could gather those applications together. But that does hit challenges if you have an application that, for perfectly valid reasons, perhaps spreads across more than one namespace. Now what do? You need some way of connecting those namespaces together. You could use network policies, which is really something you can apply to individual pods and groups of pods to describe what they can talk to, how they can talk to them, and so on. That becomes, it's certainly flexible, but it becomes quite a complex way of doing things. Another possibility is a service mesh, which would allow you to control some of the routing. And I'll talk a bit more about service mesh in a moment. And then you could go to the trouble of actually tainting certain nodes and forcing applications to land on a particular set of nodes. So going back to the traditional way of saying this application lives on these particular infrastructure nodes. Of course, that's not really very cloud native. So there's there are sometimes good reasons to do that. We want particular things to land on particular hardware, but it's generally not the sort of good practice as seen. And then the final thing that we see quite often is using the division of a cluster, the whole Kubernetes cluster, to define the boundary of an application. And so you could say, well, each application is going to have its own cluster. Now, for very good reasons, a lot of companies don't want to do that because it uses a lot more resources. It's more complex. You probably want to have Kubernetes clusters that span significant portions of your enterprise, and then they share workloads across them. That's part of the way that you get the benefit from Kubernetes. So none of these are perfect. And very much depending on the type of application that you're building, one of these approaches might suit you better than others. But let's carry on and just go back to this idea of why do we want the application boundary in the first place. So if we've started writing in a more fine-grained style, we've started building things perhaps as microservice applications, then we could end up with an ocean of microservices and very little idea of how those connect to each other at the macro level. But if we can start to bring back the idea of application boundaries using some technique, as I mentioned, there's no specific technique here, but there's many different techniques to create some kind of grouping of those microservices and to actually enforce the boundary from at least a network point of view, then we can start to say, well, okay, now I can be more clear about one microservice talking to another compared to an application talking to another over a sort of over an API that's designed to be shared. They might all be using the same kind of communication. They might all be using JSON messages over HTTP as RESTful APIs to talk within the boundary and across the boundary. And it's the fact that you're going over that boundary that makes the difference. And what is different on that boundary? Well, probably the fact that you want to introduce greater governance. So it's the fact that you want to introduce perhaps API management so that you can allow people to discover the APIs in a more straightforward way, allow them to self-subscribe to those APIs, and control the security models that they're using and so on. So very much at the edge of the application boundary starts to become the place where you put API management, but you don't necessarily need every single API that's used inside an application to sit in API management as well. So we've very much got an inside and an outside approach. Things inside the application boundary, communicating perhaps over a service mesh. We'll talk about that a bit more in a moment. And the things on the edge of the application boundary talking via API management, which is really just providing a gateway and a portal to make it easier to find the APIs and subscribe to them. The gateway providing a different type of security. So I mentioned a service mesh. So service mesh was really designed, and the one sitting, for example, in OpenShift is Istio, which is one of the more popular ones. Service mesh was really designed to enable communication between microservice components that are within a sort of specific domain, if you like, and to save you from having to put extra code and libraries into the microservice components to achieve things like circuit breaker patterns and rate limiting patterns and things like that. But it can also be used for things like introducing mutual TLS and making very specific routes across that network so that you can say, right, this particular set of components are bound to each other. They can only talk to one another, and perhaps they can only talk to each other in a certain way. There's only certain components that can talk to other components. And you can even control what requests come into the whole group and what requests go egress out of the whole group in a whitelisted style. So that's quite a powerful mechanism of effectively creating the application boundary itself. And then you can use API management at the edge of that boundary to give you the extra features that you would need to govern the APIs and make them discoverable and subscribable and so on. So service mesh on the inside and API management on the outside. There's a growing number of people using service mesh. I think it's not as common as we perhaps thought it was going to be when we first saw it being introduced, but there's certainly a growing number of people using them. So I've spoken mostly about synchronous APIs and specifically about sort of REST APIs as if that's the only kind of API that's being used today, but of course it's not. So there's historical web services, SOAP web services. There's historical messaging interfaces that people are using with IBM MQ, RabbitMQ, MQTT, and things like that. There's newer styles of HTTP interface like GraphQL. I'll talk about that a bit more in a moment as well. And then there's much more happening in the asynchronous domain. So not just messaging and MQTT, but of course, the likes of Kafka coming to the surface, the use of webhooks, WebSockets, and so on. All of these could be potentially described as an API or a type of API. They're different sets of protocols. The difference, if you like, between now and 20 years ago when I started in integration is that we used to have hundreds of standards, all of them proprietary, all of them very specific to the platforms they were working on. These are all, there's a small number of them. I say there's quite a lot on the screen, but it's still less than 10 probably. There's a relatively small number of protocols. They're all very open. They all work across standard networks and so on. So we're sort of not, we're going back to having more protocols, but it's not the proliferation of protocols that we had in the past, I hope. But it certainly is a larger number than just simply REST APIs. Just speak briefly about GraphQL. So again, we come to the idea of the application boundary again, because although GraphQL can be used in many different places, it can be used to help you gather data together from back-end systems, if you've got suitable federation servers to draw information together. So GraphQL essentially, for those of you that don't know, it allows you to talk across multiple different resources in one go and get back just the pieces that you need, whereas an interaction over REST would have been a very chatty interaction, perhaps, and you would have brought back perhaps all the information. And so, we see it being used in those sort of circumstances, but also being used within an application boundary, perhaps between a mobile user interface and the back end for front end. And that's, although in both cases we're using GraphQL, the GraphQL is very, very different in the way that it's designed, and it's also different, perhaps more importantly, in the way it's governed. GraphQL, if it's going to be exposing back-end systems, certainly needs some control and governance to ensure that it's not doing high-cost queries from a performance point of view. And so you see introduced into API management capabilities, like the ones IBM has as well, the ability to assess the cost of a query in runtime and work out whether that's safe to send through to the federation servers and the back-end systems. And so that's a very different usage of GraphQL, even though it's the same protocol. So different usages of the same API. Let's talk again briefly about this idea of asynchronous communication also being a type of API. So APIs that are REST-based are, or anything that's sort of direct synchronous HTTP call-based, you have to expect the back-end system to be present when you need it, the availability that you need. It has to perform when you need it to perform. And so you're asking quite a lot of that back-end system. And you're not as decoupled as you might think you are. You're certainly decoupled from a performance and availability point of view with the system at the other end of the API invocation chain. And so we're starting to see an increasing popularity both within the application boundary and across application boundaries of the use of asynchronous communication. It could be events from Kafka, it could be JMS, MQ under the covers, it could be webhooks or whatever. And so that idea of asynchronous communication, where you perhaps listen to the events in advance and build up a cache of the information that's occurring on the other side. And so that's become a very popular pattern. But what it, of course, means is that you then need to consider how you're going to manage not just RESTful APIs, not just GraphQL APIs, but also potentially how we're going to manage asynchronous-based APIs. And we just started to see really in the last year or so this idea of event endpoint management, which is really the equivalent of API management, but for events and messages and things like that. And that's starting to develop and mature from the raw event runtimes like Kafka all the way through to the richer, full API management facilities that can manage events as well as APIs. So bringing all that kind of together, we would be able to see that those boundaries are important. We need to work out what those application boundaries are, whether they're different to they would have been if we were basing them on physical or protocol grounds, and then recognize that the APIs we're exposing are perhaps multi-protocol, multi-form. So you've got a number of different types of interface that come together to provide an API, rather than it just being one single protocol as we would have had in the past. So an API has a different meaning in a sense now. It's something that sits at the edge of a boundary that's got a complementary set of protocols that provides what they need. So I guess I can wrap that one up by talking about what I call the fractal fallacy, because things that look similar at different scales are not necessarily the same. If you've studied mathematics or physics, you'll know all about fractals and Mandelbrot sets and things like that. And it's the idea that you can have these things that, as you delve down deeper into a pattern, you suddenly see the same pattern occurring. And we've kind of seen that today in what I've been talking about, where you might have microservice components that are brought together to become microservice applications. And the way that those microservice components talk to one another, although it might use the same protocols, is not necessarily the same as the way that a group of microservice applications talk to one another. They might need greater governance. You might need to introduce API management. As we move to applications that sit within a particular division of an enterprise, we might need to introduce another layer of control over the roles that are available to look at that. We might have different compliance controls. We're going to look at the way we handle APIs in relation to human resources differently to the way we have to handle APIs for core banking, for example. And then as we start to go outside the organization, there's going to be a whole new set of challenges in the APIs that are communicating across an ecosystem of different enterprises, perhaps dealing with industry standard data models for particular areas and things. So, as I said towards the beginning, everything is an API, but and those APIs might be the same protocol, but they're not necessarily under the covers actually the same thing. I've delved into a tiny fraction of the things that we talk about in Agile integration. I just wanted to bring something to you that was API specific and something that's a challenge that I come across with a lot of customers. Hopefully that's been a useful excursion. Plenty of links to other information around Agile integration there if you're interested. If there are any questions, I'm happy to take any in the couple of minutes I think I've got left.
Yeah, I'm looking at the comments here and not seeing anything yet. Maybe something is coming up, but so if I understood correctly, it's like APIs are like Schrodinger's cat that you have to open the box to see if it's an API and what kind of API. We kind of go to the metaphysics of it all. But
physics
question
analogy.
is that is like I heard from somebody in the industry that yeah, sorry, got me confused with that. But I just like that was the first idea that popped into my mind when listening to you. So is the API there or is it alive? That's the question. So what is the kind of most difficult thing that you see? Like, is it actually the technology and like picking the right tech for your API or for your integration, or is it actually that the human beings deciding the architecture have a tough time trying to figure out?
It's much more about the humans, and you could even have the same protocols and the same technology across all of those different types of APIs. It's the way you're using those technologies that's really going to make the difference. And the way you're enforcing particular data models or security models and so on. And so it comes down to analysis at the end of the day rather than technology choices.
Yeah. So Matt has a question. What are the ideal features of event endpoint management?
Well, I think we're only beginning to understand that because it's not quite the same as API management. So some of the features we're seeing come to the surface are things like, could I redact certain fields from the topics that I'm sharing with one audience compared to another, because I might not want them to see certain aspects? Could I filter the messages? So sort of doing things that are a bit more like event processing on top of a topic, which is not something that we put a huge amount of emphasis on in the API management space. So there are some very different qualities, I think. it's fair to say.
Yeah, and from API management point of view and opening the event-based APIs to anybody else except internally, that is not such a simple task.
Yes,
thank you.
we're seeing certainly Kafka is more prominent internally, whereas things like webhooks are more prominent externally. So protocol switching is another key feature.
Yeah, that is one of those things that you have to think about. Great. Hey, Kim, thank you for this. And I'm sure there's a lot of eager comments and chats and everything in the Hopin chat if you have time. And then